It started as a whisper, a faint pulse hidden in the static of the universe. In the early hours of July 1st, 2025, the Atlas telescope in Chile picked up a moving point of light, almost invisible against the deep black. At first, it seemed ordinary, just another frozen traveler drifting through the dark, like thousands before it. But the data refused to behave. Its speed nearly 60 kilometers per second, enough to cross the distance from Earth to the Moon in barely over an hour. And its orbit wasn't a loop around the Sun. It was open a hyperbolic path, the unmistakable signature of something that came from the stars beyond. Astronomers named it 3I Atlas, the third interstellar object ever discovered, a relic from another sun, older than ours, now slicing through the solar winds like a blade of time. For months, scientists said it was harmless a visitor, a cosmic hello before fading into darkness again. But then, something changed. The James Webb Space Telescope turned its eye toward the traveler and saw the impossible. Its brightness flickered, not randomly, but rhythmically. A mushlikar, heartbeat. Its course shifted subtly, deliberately, as if responding to something unseen. And now, it's heading directly toward Mars. Fast, silent, unpredictable. Across every observatory, alerts went out. Telescopes re-aimed. The world of science held its breath. Because this time, it's not just about a comet. It's about something that moves with purpose, something that remembers where it came from. And as 3I Atlas races toward Mars, one truth becomes impossible to ignore. The universe just got personal long before it was named. Astronomers knew they were looking at something extraordinary. The object's velocity, direction, and hyperbolic escape path confirmed what many had quietly suspected. This traveler didn't belong here. It wasn't born from the dust that built our planets, nor shaped by the gravity of our sun. 3I Atlas became the third confirmed interstellar visitor ever detected, following Oumuamua in 2017 and Borisov in 2019. Each arrival felt like a message short, brilliant, and impossible to ignore. But this one was different. Larger, faster, stranger. Its chemistry and motion hinted at origins buried deep within a crowded stellar nursery. Somewhere in the Milky Way, a place where suns are born too close and die too young. At nearly 60 kilometers per second, it was moving through our solar system, as if crossing foreign territory, obeying laws of physics, but not our sense of familiarity. Every curve in its path seemed to whisper of another world's sky, another sun's pull, another history written in a language of light. If it truly formed somewhere else, then it carries a story that does not belong to our solar system. When scientists measured the light reflected from its surface, they realized just how massive this traveler truly was. Early estimates placed the nucleus at about 5.5 kilometers wide, but newer observations pushed that number closer to 11. That makes 3I Atlas almost twice the size of Borisov, and far beyond Oumuamua's tiny frame. To put that in perspective, a body 11 kilometers across, moving faster than 60 kilometers per second, about 130,000 miles per hour. At that speed, it could circle the entire Earth in just 7 minutes. The sheer size and momentum make this object unlike any interstellar visitor we've ever recorded. It doesn't slip quietly through the dark, it carves through space. leaving the faintest tremor in the data of every instrument pointed its way. When you are that large and that fast, you're no longer a passing visitor, you're an event. Something unusual happened long before the comet ever reached the inner solar system. At a distance of nearly 3.8 astronomical units, more than 560 million kilometers from the Sun telescopes, detected the first signs of a tail forming. That shouldn't happen. Comets usually wait until sunlight warms them far closer in, when ice begins to vaporize and jets of gas escape into space. But 3I Atlas was already active, breathing out carbon dioxide and other volatile gases, while still deep in the cold. Observers also noticed something stranger, a faint anti-tail pointing toward the Sun instead of away from it, a geometry that can only be seen from certain angles, but one that challenges how we expect dust to behave. The comet's jets seem to pulse, brightening and fading, as if responding to some unseen rhythm. Its ratio of carbon dioxide to water vapor, far higher than any local comet, hinted that the material under the surface was forged in a much harsher environment. If it doesn't behave like a comet, then perhaps it's sending a message beneath the ice. Every comet tells its story through light. When sunlight strikes the dust and gas, each molecule sings in its own color, leaving fingerprints across the spectrum. And when astronomers analyzed the light from 3I Atlas, those fingerprints didn't look familiar at all. The ratio of carbon dioxide to water vapor was astonishing, nearly 8-to-1. No comet in our solar system has ever shown chemistry like that. In most cases, water dominates. Carbon dioxide is just a faint echo. Here, it's the other way around. That imbalance suggests an origin near the carbon dioxide ice line, a boundary far from any star where temperatures are low enough for carbon dioxide to freeze solid while water remains trapped deeper below. Perhaps it formed in the shadow of a dying sun, a place flooded with ultraviolet radiation and stripped of its warmth. Each spectrum captured by the Webb and Hubble telescopes repeats the same story, a stubborn chemistry that refuses to fade. As if preserving the memory of the world it came from. When you discover chemistry that doesn't belong to the place you stand, you've already arrived somewhere else. The moment 3I Atlas entered the reach of our best instruments, humanity turned its largest eyes toward the sky. On July 21st, the Hubble Space Telescope captured the first high-resolution images, a thin emerald glow stretching across the black. Just weeks later, on August 6th, the James Webb Space Telescope locked onto the traveler with its NIRSPEC instrument. Webb's infrared vision cut through the dust and revealed the comet's hidden chemistry, a world of frozen carbon dioxide shimmering beneath layers of ice. Meanwhile, SPHERES, NASA's upcoming spectral explorer, scanned the object between August 7th and 15th, collecting light from ultraviolet to infrared, a complete fingerprint of everything the comet was made of. Dozens of ground-based observatories joined in Gemini South in Chile, Subaru in Hawaii, and the European Southern Observatory, each capturing a different layer of truth, each frame a piece of the puzzle. The world's instruments are now watching in unison, waiting for something to shift, something that doesn't fit the pattern. And they're still waiting for the next anomaly to appear. In astronomy, timing is everything. For 3I Atlas, 3 dates mark the narrow window when the universe lets us peek behind the curtain. Each one offers a different kind of truth, a different heartbeat of the same traveler. October 3rd, 2025. The comet makes its closest pass to Mars about 30 million kilometers away. For the orbiters circling the red planet, this is a front row seat. Instruments aboard ESA and NASA probes will scan for any dust interaction or magnetic disturbance as Atlas cuts through the Martian sky. October 30th. Perihelion, the closest approach to the Sun at about 1.4 astronomical units. Roughly 210 million kilometers. This is when the comet's body will heat, vent, and possibly reshape. If anything unusual happens, it will happen here. After that, the traveler slips behind the Sun, invisible from Earth until December. For nearly 6 weeks, telescopes will fall silent, waiting for it to re-emerge on the other side. Changed or unchanged, 3 dates, 3 chances, and 1 moment that could rewrite what we know. For a few weeks each year, the universe simply turns its face away. 3. I Atlas is now slipping behind the Sun, a period astronomers call conjunction. When observation from Earth becomes almost impossible, the glare of the solar disk drowns out every signal, every photon. For NASA and ESA's instruments, it's a forced silence. Commands pause, data streams flatten, and what once was a living feed becomes a blank screen. But that blankness doesn't mean nothing is happening. It only means we can't see it. The universe speaks in patience. It hides what it must, reveals what it chooses, and in between, it asks us to wait. Emptiness isn't the absence of information. Sometimes it's the sign of something too vast to be seen. And when it returns from behind the Sun, you'll see everything differently. Every mystery needs a framework, a way to separate what we believe from what we can prove. That's why we built the Alien Tech Scorecard, a living scale that tracks how far 3i Atlas climbs up the ladder of evidence. 5 criteria define the scale trajectory: spectral ratio, morphology, signal repetition, and water outgassing rate, each worth 20 points, together forming a complete 100, with new data confirming its size up to 11 kilometers across and an unusually high carbon dioxide ratio. The object now earns a starting score of 32 out of 100, not proof, but curiosity made measurable. Quake. We'll update the chart as new readings arrive. Every fluctuation in light, every hint of activity adding or subtracting from the total. Next week, if the water outgassing rate increases, the score could jump to 50. October 3rd, 2025. The date circled on every astronomer's calendar. That's when 3i Atlas makes its closest pass to Mars roughly 30 million kilometers away. In cosmic terms, that's barely a handshake, while no collision is expected. The proximity itself is historic. At such distance, even faint streams of gas, dust, or magnetic wake could brush against the Martian environment, an opportunity for every orbiter and rover to witness an interstellar encounter up close. Scientists are preparing coordinated observations. Hubble, Webb, and every eye on Mars will watch as the traveler glides past the red planet's orbit. What they see may redefine how we imagine interstellar matter interacting with planetary systems. 30 million kilometers apart in space. That's a single step. Interstellar visitors are the rarest messengers in the cosmos. In all of human history, only 3 have ever been seen: Oumuamua, Borisov, and now 3i Atlas. Each one a sealed package, drifting across the galaxy for eons before arriving at our doorstep. Scientists from the SETI Institute describe them as time capsules, fragments of alien systems carrying the chemistry, radiation, and rhythm of suns long extinguished. If 3i Atlas truly formed in another stellar domain, then its composition is a map, a record of how another solar system once breathed, lived, and died. And if you could touch it, you wouldn't just touch a comet, you'd touch the past of a star. Science is rewriting the story. Silence is waiting for the answer. Between those two forces, humanity stands listening, questioning, measuring. The Alien Tech Scorecard will keep tracking 3i Atlas, updating each anomaly as it unfolds. Follow the data. Follow the light, and join us as we climb the ladder of evidence together. Leave a comment. What's your score? This week, 32, 40 or 50 when the outgassing begins to rise. Truth doesn't need impact to reveal itself. It only needs to be seen.